Okay, now we're going to look at this, the first chapter untuk hari ini, okay, which is digital logic overview. Okay, so in this digital logic overview, okay, you will learn about the digital and analog quantities. Okay, what is digital? What is an analog? Okay, what are the difference between digital and analogs? And then after that, we are going to look at the binary digits, logic level, and digital waveform. So this is the characteristic of the digital signals. Okay, kita akan look more details on this digital signal studies. Okay, so first let's look at the digital and analog quantities. Okay, so this is the definition of analogs and digitals. All right, so what is an analog? Okay, before that, okay, so electronic circuits can be divided into two types. Okay, satu adalah analog circuits and the second one is digital circuits. Okay, so what is an analog circuit? What is digital circuit? Okay, before we go more details on that part, we need to look at the dia punya definition of analogs. Okay, so analog is a quantity that has a continuous set of value. Okay, means that every time you hear the word analogs means that dia punya quantity adalah dia punya values adalah continuously. Okay, so it is a variable of signal continuous in both time and amplitude. Okay, for example here, okay, you're going to take a temperatures. Okay, so this temperature here will measure continuously daripada pukul 12 tengah malam sampai 12 tengah hari. Okay, it will taken daripada pukul 12 tengah malam until the next 12 tengah malam. Okay, so the readings of the temperature is taken continuously. Okay, every seconds. Okay, tanpa non-stop. Okay, so that is what we call it as a analog signal. Okay, which is the quantity that has a continuous set of value, means that you take the values continuously. Okay, so example of analog system is, for example, a temperature, okay, change over a continuous range of value. Okay, so this is an example, or by looking at this, what we call graph here. Okay, other example means contour, pressure, distance, and sounds. Okay, so that is a analog signal. Okay, next we are going to look at the digital signal. Okay, the digital signal is a quantity that has a discrete set of value, means that you take the value discretely. Okay, previously benda yang sama. Okay, as the same examples here. Okay, you're going to take a temperatures. Okay, started from pukul 12 tengah malam sampai the next 12 tengah malam. Okay, you can see here, but rather you take it continuously, tetapi sekarang ni kamu take it discretely. Okay, means that you take every hour. Okay, kamu setiap sejam kamu ambil dia punya temperature. Another jam, okay, you take another temperature. So this is what we call it as a discrete set of value. Okay, previously continuous set of value. Okay, so that is the difference between analogs and digitals. Okay, so another perbezaan, okay, another comparison between analog and digital signal is analogs, okay, selalunya use base 10, okay, which is a decimal number. Okay, analog system always use base 10, asas 10. Okay, and it will be represented by a 10 different level, which is from number 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, so analog system or analog signal always use a base 10. Okay, asas 10. Why? For the digital system, okay, it use base 2, okay, which is asas 2. What is asas 2? We call it as a binary number. Okay, so what is the base 2? Base 2 will be represented by two different levels. Okay, either it is a logic 0 ataupun logic 1. Okay, dia ada 2 level saja, sama ada 0 sampai 1. Compare to this one here, dia ada 10 level. Okay, which is daripada 0, 1, 2 sampai ke 9. Okay, regarding of the system, okay, analog system is a combination of a device that manipulates values represented in analog form. Okay, so example of analog system seperti analog watch. Okay, we have a jump analogs, and then previously we have a analog phone. Okay, which is the one that kalau kamu ingat lagi, okay, yang dia ada dial tu yang kita kena setiap kali nak call kita kena pusingkan dia punya nombor untuk masukkan nombor. Okay, and for the digital system, okay, so the digital system is a combination of devices that manipulate value represented in digital form. Okay, example of digital signal is digital watch and mobile digital phone. Okay, so digital watch macam kita punya smartphone, smartwatch sekarang lah, which is it. Okay, it will the watch is represented by the digital number. Compare yang analog watch, which is masih lagi digunakan sekarang, the one that we have the pointer lah, ada jarum panjang dan jarum pendek. And then now we more of the telephone here today's are from the mobile digital phones. Okay, so next, okay, we are going to look at what are the advantage of digital system. Okay, kenapa kita nak guna digital system? Okay, the first one here is it is easy to design, and then information storage is easy, accuracy and precision are easy to maintain, operation can be programmed, less affected by noise, and more digital security can be fabricated on IC chips. Okay, in the next slide, we will see more details on this advantage yang list out dekat sini. Okay, first, let's look at the easy to design. Okay, why the digital system or digital signal is easy to design? Okay, because there are only 2 different voltage to be considered in the digital signals. Okay, kalau kamu recall back tadi, digital signal consists of a binary number. Okay, which is
0 and 1.
Di mana saya punya ni? Okay, 0 ataupun 1. Okay, so 0 is we always panggil dia sebagai logic low, while 1 we call it as logic high. Okay, so that's why it is easy to design. Kenapa? Sebab dia hanya ada 2 nombor saja, ada either logic 0 and logic high. Okay, contoh. So this is a contoh. Okay, we have the analog signal yang kita measure. Contoh kita ambil a temperature lah. Okay, so any value. Okay, so the maximum value here, kalau kamu tengok sini, dia punya voltage. Okay, that coming from your sensors, your thermometer sensors. Okay, contoh di sini, dia punya minimum value is 0 volt and maximum value is 5 volt. Okay, so now what happened here? For digital system, since the digital system only have 2 values, sama ada logic 0 atau logic 1. So what happened here? From this value here, okay, from 0 to 5, okay, kita akan bahagikan dia kepada 3 bahagian. Okay, for in this case here, yang ni 0 volt sampai ke 0.8 volt, okay, we call it as a voltage low. Okay, so this any value fall in this what we call here, in this range, will be considered as a binary 0 ataupun logic 0. Okay, and for the logic high, okay, which is binary 1, okay, any value that fall between 5 volt to 2 volt, we call it as a logic 1. Okay, and then in between here, this is an unacceptable. So this is what happened lah. Okay, kalau contoh kamu ada, so this is the bacaan yang kita ambil. Okay, so kamu ada sensors. Okay, from the sensor, it produce this value here. Contoh so this is the values. Okay, contoh yang ni 2.0 volt. Okay, so this is voltage and this is a voltage and this is a time. Okay, so this is a 5 volt and this is 2.0 and then this is a 0.7 and then this is a 0.6. Okay, so sekarang ni we have this discrete signal. Okay, now you're going to convert this discrete signal to digital signal. So what happened here is, okay, so any value, okay, that is between this region here, dia akan jadi logic, what we call logic 1. So what happened here is, okay, so this is a time 1, time 2, time 3, 4, 5. Okay, so this is a time and this is a logic signal lah. Okay. So time 1, kalau kamu tengok sini, dia is a 2 volt, so dia akan jadi logic 1. Okay, dia ada dua je value, sama ada 1 ataupun 0. So in this value here, okay, in this part here, since this is a 2.0 and it's fall under, okay, so the system will consider as a logic 1. Okay, untuk masa yang kedua, okay, which is 2 seconds, okay, so this is a 5 volt, so this one also will produce a logic 1. Okay, so this one, logic 1. And 3, since 3 also 2 volt, so this one also produce a logic 1. Okay, what about 4 and 5? Okay, since 4 and 5, okay, kalau kamu tengok kat sini, 4 and 5, the value is 0.7 and 0.6, which is
Logic
according
kosong.
to this, ni dia akan produce logic 0. So
Zero.
that's why nanti later kalau kamu tengok dia punya graph akan jadi macam ini. Okay, so now you already produce a logic signal kat sini. Either 1 ataupun 0 based on this value here. Okay, so that's why the digital system easier to design. Kenapa? Sebab dia hanya ada dua value, antara 0 ataupun 1. Okay, next. Information storage is easy. Okay, so why? Because it can be kept as long as necessary in digital memory and it can be stored more compactly. Okay, contohlah. Okay, we have this is a analog system and this is a digital system. Okay, a few years back, okay, untuk dengar video, untuk dengar lagu, kita ada cassette player. Okay, which is all the lagu will be stored inside of this cassette. Okay, the drawback of this cassette here, okay, contohlah kalau kamu ada cassette tu 70 minit, okay, dia punya tape ni, okay, only cater up 70 minit. So bilangan lagu yang kamu boleh letak dalam cassette ini adalah tak banyak. Okay, mungkin kamu boleh letak paling banyak pun 15 lagu saja. Okay, compared to this digital signal, okay, which this digital signal system, which is, okay, you can put more lagu inside of this CD. Okay, kamu boleh burn banyak lagu inside of this CD. Contohlah dulu CD kita punya dia punya capacity is to 700 megabit. Okay, kalau kamu burn ataupun kamu store your MP3, okay, it can up to 1,000 lagu or 10,000 lagu, depending on the size lah of that lagu. Okay, most of the time boleh thousands lah untuk CD. Okay, because CD is only 700 megabyte, unless you use a Blu-ray ke. Okay, so the size is bigger. Okay, so that's why here you can see cassette. Okay, for the analog system, okay, the number of the song that you can put is less lah compared to this CD. Okay, and then for the cassette, kalau kamu expose cassette ni dekat panas, okay, the quality of the cassette might be deteriorate. Okay, the quality tak sama dengan yang baru lah, yang baru kamu beli. Okay, bila kamu sambungkan dia kepada cassette player, okay, mungkin dia punya bass tu ataupun dia punya lagu tu tak macam yang awal-awal kamu beli. Okay, kenapa? Sebab yang ni, okay, since this one here, this cassette is the lagu here bergantung pada continuous signal. Okay, if there is a noise here, so what happen? Okay, the value will be deteriorate. Okay, the signal on this cassette here lagu kat sini akan berubah lah. Okay, compared to CD player, okay, the CDs here, okay, since we only have two values, even though there is a what we call here noise kat sini, okay, this noise will consider either as logic 0 or logic 1. So that's why here, okay, the digital system is advantage lah. It is not prone to the noise compared to this analog system. And for the digital system, okay, you can store more data inside of this CD compared to the analog system. Okay, so that's why this is another advantage lah of the digital system. Okay, kalau nak dibandingkan dengan analog system. Okay, so this is another example lah. Okay, sekarang ni kita dah tak pakai CDs lagi. Okay, we will storing on this memories here. Okay, we have the pen drive. Okay, you have a micro SD cards and you have the portable hard disk. Okay, so depending on the size here, okay, you can put a lot of data inside of this kita punya memories. Okay, so next, okay, number 3 is accuracy and precision, easy to maintain. Okay, so the digital signal does not deteriorate once it is stored. Okay, so the what we call here, the quality of the digital signal, okay, will not tak akan berubah lah. Okay, kenapa? Sebab kita hanya store sama ada dia dalam either is a logic 1 ataupun logic kosong. Okay, but the analog information may be distorted by the effect of temperature, humidity, and etc. So this is why I told earlier lah. Okay, kalau kamu what we call here, kamu dedahkan, okay, kamu put your cassettes, okay, expose your cassette to the matahari, okay, sun, under the sun, okay, for the long period of time, the quality of the cassette will be distorted, okay, will be deteriorated, okay. Next, we have the operation can be programmed, okay, if you're using the digital system, okay, it is easy to program and reprogram the operation of the digital system, okay. Yang paling mudah sekali kita ambil kamu punya pen drive lah. Okay, you can easily transfer or delete your data inside of your pen drive. Okay, meanwhile, the operation in the analog system are more complex and it is difficult to program. Okay, boleh program, but you need to have a special device lah untuk programkan dia. Okay, compared to the digital system, okay, it is easy to program and reprogram. And D, less affected by noise. Okay, so macam yang saya bagi tahu tadi, okay, the digital system, okay, the signal is less affected by noise. Why? Because the exact voltage not important in the digital system. Okay, kenapa kita hanya fokus on two logic here? Either is a logic high or logic low. Okay, compared to analog system, okay, contohlah, so this is original signal, kamu punya analog system. Okay, kalau tiba-tiba this signal here is deteriorated by noise, so dia akan jadi macam tu. So the quality is not tak sama macam yang asal lah. Okay, which is it already contaminated with a noise. Okay, so since this is a continuous signal, so when it's stimulated with noise, so they akan affected of the quality. But for the digital system, okay, dia hanya ada logic 1 and logic 0. Okay, even though ada noise kat sini, hilang pula. Okay, so okay, even though ada noise dekat logic 0 and logic 1, but this one here will still be considered as kosong and satu. Okay, so this noise here will not affect the quality of the signal. Compared to analog systems, okay, if you have a noise, then the noise will akan rosakkan dia punya quality lah of the signal. And last but not least is more digital circuit can be fabricated on chips. Okay, so analog components such. Okay, so this is untuk analog component. Okay, we have capacitors, resistor, inductors, and transformer cannot be economically integrated. Okay, since we for the analog system, okay, it will consist of these components here. Okay, since you have a lot of components, then what happen here is the size of that system will much bigger compared to digital circuit. Kenapa? Sebabnya kamu kena pakai capacitor, kamu kena guna resistor untuk hasilkan analog circuits. Okay, compared to the digital circuit, okay, so the digital circuit easily fabricated using a silicon technology, which is a cheaper and easy to produce. Okay, so that's why lah kalau kamu beli integrated circuit, ya, okay, kalau kamu pergi ke kedai, kamu ada nampak ICs, okay, so that's one is a digital circuits lah. We call it as a integrated circuits. Okay, and then now we are going to look at the limitation of the digital system. Okay, so the first one here is the real world is in analog signal. Okay, so this is the first drawback lah of the digital system. Kenapa? All of the real world signal is in a analog. So what happened here is sebelum kita gunakan convert it to the digital system, kamu kena convert dahulu analog signal ni kepada digital signal. Okay, and pre-processing digitized signal will take time. So this is a dululah. Okay, now because we have new technologies, okay, the processing to digitize a signal, okay, much simpler than previously. Okay, and short product half-life. Okay, so this is yang paling critical lah. Okay, what is the meaning by the short product half-life? Okay, means that you need to catch up with a new technology once available. Okay, contoh lah. Okay, I give you a contoh. Okay, in a few years back, okay, untuk kita tonton, we are going to look, watching for a movies. Okay, kita tengok video movies. Okay, we going to use a VCD player. Okay, to watch a movie. Okay, previous years back. Okay, kita ada VCD player. Okay, so then, okay, sebelum tu we have a VHS lah. Okay, yang tape tu. Tapi yang tape tu is analog sense, like analog. Okay, then untuk yang digital we use a VCD. Okay, we have a VCD player, and then after 1 or 2 years, lepas tu apa pula? Okay, DVD player is introduced. Okay, what happened to the VCD player? Kamu dah beli dah ni VCD. Okay, kamu dah beli banyak CDs. Okay, CDs movies. Okay, what happened when the DVD player is introduced? Okay, kamu dah tak boleh guna this CDs to this DVD player. Okay, you cannot, you no longer can use this CDs here, okay, to play inside of the DVD player. So what happened here is, okay, you need to beli pula DVD player to play a DVDs. Okay, movie yang dalam bentuk DVDs. Okay, and then after that, 1 or 2 years later, now Blu-ray is introduced. Okay, alamak. Okay, so tadi VCD, and then DVD, and then after that 2 years after that, okay, comes
Blu-ray.
Blu-ray pula, okay, introduce. So what happened? DVD and VCD, okay, yang kamu beli sebelum ni tak boleh play on the Blu-rays, okay? Sebab CDs tu boleh play, but okay, if you sebabnya pada masa ni, okay, so what happened here is all of the movies now dah dikeluarkan dalam bentuk Blu-ray. So what happened here? This Blu-rays here tak boleh play on the DVD and VCD. So what happened here is you need to buy the Blu-rays player pula after that. Okay, so you need to replace again in order to watch a movie. Okay, so this is the what we call it as a short product half-life lah. Okay. Okay, so sekarang ni nak tengok movie, okay, so you can streaming, okay, so you can watch it on the Netflix or so no problems lah sebab sekarang ni semuanya kita boleh streaming, so no problems lah regarding of this technologies here. Okay, so this is what happened lah. Okay, in the real world, okay, all the apa ni kita punya signals are in an analog. So what happened here is, okay, so you need to convert from analog to digital signal. Okay, contohlah dekat sini. Okay, so you have a CD drive. Okay, so you're going to look at these movies here. Okay, so inside of these CDs you have a movie. So what happened here is kamu kena convertkan dahulu from this CD drive, okay, by using to digital to analog converter. You need to convert these digital signals to analog signals. Okay, once converting is done, then after that you can display it, okay, to the speakers or to the monitors, okay, to watch the movie. Okay, because all the quantities, okay, in the real world quantities is in analog, so you need to have a satu system lah untuk convert daripada analog ke digital. We call it as a analog to digital conversion. And after that, after you did the processing and then you're going to tengok balik, okay, we need to have another system here. We call it as a digital to analog to convert back the digital system to analog signal. Okay, and system using digital and analog methods. Okay, so although a digital system has many advantages, okay, real world quantities are analog. Okay, so therefore there is a need to convert between analog and digital signals. Okay, contoh kat sini. Okay, kamu tengah buat apa ni, public speaking. Okay, there is a lot of audience there. Okay, if you bercakap, okay, tanpa menggunakan apa-apa device, so might be people at the back tak boleh dengar apa yang kamu cuba sampaikan. So what happen here is, okay, you need to have a amplifier lah, okay, satu system to amplify your voice, okay, which is come out free block. Okay, so this amplify system is using a mic, okay, to retrieve your voice. Okay, so since our voice is from analog, okay, kamu punya, okay, kita voice is in an analog. So what happened here is this mic here akan convert this analog, okay, analog value to kita panggil dia sebagai electrical value, which is either dalam bentuk volt ataupun millivolt. Okay, so this microphone here will convert this analog value to electrical signals, okay, sama ada dalam voltage ataupun ampere, okay, dari voltage ataupun ampere. Okay, from here, okay, this electrical value here, either is a voltage or ampere, will go to the ADC, okay, which is ADC is an analog to digital conversion. Okay, based on the analog to digital conversion, so what happen here is this analog system akan ditukar kepada digital system, digital signal. So kat sini dah jadi digital signal. Okay, so from this here, okay, analog system, Okay, microphone akan tukarkan dia kepada electrical signal. Okay, from here it will convert to the digital signal. Okay, then we have the digital signal processing. Okay, what this digital signal processing do? Okay, so this digital signal processing will do a processing lah. Sama ada kamu nak buat filtering, okay, nak buang noises, hanya keluarkan suara kamu saja, tak nak dia punya ambient noise semua tak nak. Okay, so we will do it inside of this SP. Okay, so we have a filter system, ataupun kamu nak amplifykan dia. Okay, so we have an amplifier. Okay, so from here, the signal here, okay, so contohlah yang ni signal dia dalam millivolt. Okay, so now you amplify, so dia akan jadi makin besar. Okay, so this is what happen inside of the digital signal processing. Okay, so at the same time, okay, kamu boleh simpan dia, okay, save it to the memory, sama ada nak save ke dalam pen drive, nak save ke dalam hard disk or whatever. Okay, so since this is kat sini dalam bentuk digital signal, so it's easy to save it into the memories lah. Okay, and the storage quite big lah kat sini. Okay, kamu boleh simpan whatever you do it here. And to amplify the untuk amplify this voice ya, okay, apa yang kamu cakap ni, so what happen here is you need to convert balik, okay, this digital signal here ke dalam bentuk analog, okay, by using the DAC, okay, digital to analog converter. Okay, so tadi signal kamu besar ni, okay, so sekarang ni dah jadi besar ni, okay, sebab kamu dah amplify dekat sini tadi. Okay, you already amplify here, so now the signal will become bigger, and after that it will go to this speaker, and the people at the back boleh dengar apa yang kamu cakap kat depan ni. Okay, so this is how the digital and analog system, okay, works lah. Okay, from analog tukarkan dulu kepada digital signals, and then you can do after kamu tukar kepada digital signal, you can do whatever you going to do inside of this digital signal processing, sama ada kamu nak buat filtering, kamu nak amplify, ataupun kamu, okay, all banyak benda lah kamu boleh buat kat sini, or you can going to put it, simpan ke dalam you punya pen drive, and then after that to, okay, then after that from here kamu kena ada another circuit, we call it as this AC, okay, supaya okay, this signal here will be convert back to the analog signals, and then it will be put to the speaker ataupun will be displayed to the monitor. So this is how the system works. Okay, any question up until here? Ada soalan tak?
So far boleh faham lagi dok.
Okay, so if no question, next we move on to the next slide. Okay, so this is only the introduction part lah. Okay, the first chapter is only the introduction part. Okay, it's maybe sometimes it's quite boring lah for the introduction part. Okay, now we're going to look at the digital logics level and digital waveforms. Okay, so first kita nak tengok binary digits. Okay, so digital electronics involve circuits and systems that are only two possible states. Okay, so every digital electronics or digital circuit, dia akan hanya ada dua values. Okay, either logic high ataupun logic low. Okay, or we can call it as a logic 1 or logic 0. Okay, so each of the 1 and 0 is called a bit in binary digital system. Okay, so setiap kali kamu nampak 1 and 0, we call it as a bit. Okay, contoh. Okay, I give you contoh. 1011. Okay, ada berapa bit kat sini? Ada 4
Bit.
bit. Okay, so if you have a 1011 1000, so this is we call it as a 8 bit. Okay, so 8 bit sama dengan 1 byte. Okay, and if you have a 16 bit, okay, so sama dengan 2 bytes. Okay, and it will keep continuous lah benda-benda ni. Okay, so the number of 1010 ni will determine the number of bit lah. Sama ada 4 bit. Okay, kalau dia ada 4 value, okay, 4 nombor kat sini, so 4 bit. Contohlah komputer kamu sekarang ni 32 bit. So what happen here? So this your computer can process this value lah. Ada 32 bit value ni at one time. Okay, so that we call it as a 32 bit computer. Okay, the data is quite bigger lah. Okay, sebab dia ada 32 bit. If you have 64 bit, okay, so you have a 64 numbers ni lah. You can process at one time. Okay, so this 1010 ni kita panggil dia sebagai bit. Okay, so this is binary digits. Okay, and next we are going to look at the logic levels. Okay, what is the logic level? Okay, so the logic level is the voltage used, okay, to represent a bit logic 1 ataupun high, and logic 0 or low are called a logic level. Okay, means that logic level ni, this logic, the value yang akan represent either bit 1 ataupun bit 0. Okay, contoh. Tadi kita ada analog signal. Okay, analog signal nak tukar kepada digital signal, kamu kena look at this logic level. Okay, di mana this logic level will determine lah. Okay, signal ni akan jadi logic 1 ataupun logic 0. Okay, so in this case ya, kalau kita tengok pada rajah ni, okay, so every value that fall between 5 volt hingga 2 volt, we call it as a bit 1. Okay, so this is the logic level. Logic, okay, any value that falls from 2 to 5 volt, we call it as a logic 1. And then for the logic 0, any value that falls between 0 to 0.8 volt, okay, we call it as a logic 0. Okay, ataupun logic low. Okay, so this is a logic level. Okay, the voltage used to represent either 1 or 0. Okay, yang ni untuk yang maximum value 5 volt lah. Okay, sometimes you have your circuit can up to 12 volt, 20 volt. So later you need to ni lah, kamu kena tentukanlah dia punya logic level. What is the voltage to represent logic 1 and what are the voltage to represent logic 0. Okay, so that what we call it as a logic levels. Okay, then we go to the next slide, which is a digital waveform. Okay, so what is the digital waveform? Okay, the digital waveform consists of a voltage levels that are changing back and forth between high or low. Okay, maksudnya kat sini, kalau kamu ada waveform macam ni, okay, so yang ni kita panggil dia sebagai digital waveform. Okay, kenapa? Sebabnya kamu ada consist of logic level 0 and 1 in the single waveform. Okay, and this digital waveform boleh dibahagikan pada dua jenis. Okay, first we call it as positive logics, then the second one is a negative logics. Okay, what is positive logics? Okay, so this is a positive logic lah. Okay, whatever logic 1, we call it as a positive logic. Okay, sometimes we call it as an active high lah. Okay, so kalau kamu nampak yang produce satu ni, so this is a logic positive logics. Okay, so this one is a positive logic. Yang ni positive logic positive logic, and this one is positive logic. Okay, for the positive logic, okay, kalau tengok ini, okay, dia ada dua edge. Okay, this one, okay, yang ni kita panggil dia sebagai rising edge. Kenapa rising edge? Sebabnya dia berubah daripada logic 0 ke logic 1. So that's why we call it as a rising edge. Okay, meanwhile, if yang ni, edge yang ni kita panggil dia sebagai falling edge. Kenapa falling edge? Sebab kamu tengok kat sini, okay, dia asal-asal value dia 1, now dia turun kepada 0. So this edge here kita panggil dia sebagai falling edge. Okay, so this is untuk positive logic. Okay, for the negative logic, okay, so for the negative logic, where we are going to look at this logic 0 kat sini. Okay, so every logic 0 yang ni kita panggil dia sebagai negative logic lah ataupun active low. Okay, and then dia pun ada dua edge, okay, rising edge and falling edge. Okay, so falling edge yang ni lah. Okay, you see daripada 1 ke 0. So this one we call it as a falling edge. 0 ke 1 we call it as a rising edge. Okay, so there is a difference between either active high, active low. Yang ni nanti kamu akan tengok lah in the next chapter. Okay, you will frequently use this term here. Sama ada active high atau active low. Kalau active high kamu tahulah. Okay, dia hanya active bila logic 1. If active low means that it will be active when the logic is kosong. Okay, so this is for the digital waveform. And this digital waveform boleh dibahagikan kepada dua jenis pula. Okay, what is that? Periodics and non-periodics. Okay, what is a periodics and non-periodics? Okay, for the periodics, okay, kalau kamu tengok ni, dia punya size dia sama. Okay, from first signal to the second signal to the third signal. Okay, the period for each of these signals here sama. Okay, so this is the period yang kita ambil daripada sini ke sini. Okay, so this one we call it as a T ataupun period. Okay, so this T here sama from T1, T2, and T3. Okay, so if the period sama, yang ni yang sama dengan yang ni, sama dengan yang ni, so we call it as a periodic signal. Okay, which is the signal keep repeating after a period of time. Okay, for the non-periodics, okay, it doesn't have the same period. Dia ada period, tapi period dia tak sama. Okay, contoh, saya lukis ya sekejap. Okay, kalau kita tengok yang ni, okay, kita ambil from starting here for here. Okay, so this is T1. Okay, and then from here to here, this is a T2. T1 tak sama dengan T2. Okay, and then when you take this one here, okay, so this is the T. Sorry, sampai sini ya. Sini, sampai sini. Okay, so this is a T3. And yang ni kita ambil yang ni sampailah sini. Okay, so this is a T4. So you see the T1 tak sama dengan T2, tak sama dengan T3, tak sama dengan T4. T dia berbeza-beza. Okay, the period is berbeza from one signal to another signal. Okay, from one waveform to another waveform. So we call it as a non-periodic waveforms. Okay, and from here, if you will get the T, okay, this is for the periodics lah. Kamu boleh dapatkan dia punya frequency. Okay, so from this waveform here, okay, from the digital waveform, kita boleh dapatkan dia punya period, and at the same time, we can get the frequency. Okay, so how to get a period? Dia macam sebelum ni, kalau kamu ada sine wave, sama jugalah. Okay, so daripada sini ke sini, okay, yang ni, so this is a T. Okay, one full cycle lah, kita panggil dia sebagai one full cycle. This is your period. Okay, one cycle sama dengan T. Yang ni pun sama juga. Kalau kamu tengok ni, starting from here and ended here. Okay, so this is what we call it as one cycle. Okay, so this is your T. Okay, so one full cycle, kamu akan dapatkan dia punya T. So T is your period. And from this T, you can get the frequency. Okay, how to get a frequency? Frequency sama dengan 1 over T. So this is the formula. Okay, so what is this frequency? Okay, so the frequency is the rate at which the pulse waveform repeat itself. Okay, berapa banyak kali the pulse waveform repeat itself in 1 second. Okay, so this rate here, okay, this frequency is measured by cycle per second. That's why 1 over T, cycle per second. Okay, another name we call it as a hertz. Okay, so frequency adalah diukur dalam bentuk hertz. Okay, meanwhile period T is the time the age of one pulse to corresponding age of the next pulse. Mean that one clock cycles. Okay, so you will get the period. Okay, and this period here is measured in seconds. Okay, dalam saat. Okay, so this is the ni lah dia punya persamaan. F frekuensi sama dengan 1 over T. Okay, if you have T, you can get F, and if you have F, you can get T. Contoh, okay, a clock frequency F sama dengan 100 Hz. Okay, kamu ada frekuensi 100 Hz. Okay, now you're going to find out what is a T. Okay, so T sama dengan 1 over F, which is 1 bahagi 100. Kamu dapat 0.01 seconds ataupun 10 milliseconds. Okay, so from this frequency, you can get your period T, or from this T here, you can get back the F by using the same formula. Okay, so from this waveform here, okay, kamu boleh dapat dia punya period, dan pada masa yang sama kamu boleh dapat dia punya frekuensi. Okay, and next, apa lagi kita boleh dapat daripada waveform? Okay, the next one here, we can get another parameters here, which is a pulse width. Okay, so what is a pulse width? A pulse width is a measure of the duration of a pulse. Okay, so dia macam ni. In reality, okay, the transition between rising and falling age never occur instantaneously. Okay, maksudnya kat sini, okay, ideally digital signal kita nak bentuk dia macam ni. Okay, logic 0 bila dia tukar kepada logic 1 berlaku pada masa yang sama. Okay, the changes from logic 0 to logic 1 or from logic 1 to logic 0 occurs at the same time. But in reality, okay, the changes is not, okay, between rising age and falling age never occur instantaneously. Okay, tak berlaku pada waktu yang sama. Dia akan ada semacam ni lah bentuknya nanti. Okay, contoh yang ni dia akan jadi macam ni. Okay. Okay, you will never get this sharp edge kat sini. Yang bucu petak ni tak akan dapat. This in reality lah. Ideally memang kita nak bentuk dalam macam ni untuk digital signal, but reality will only get something like this. Okay. So since in reality, okay, the digital waveform is something like this. So what happen here is we need to find the pulse width, rising time and fall time. Okay, macam mana nak dapatkan pulse width? Okay, pulse width ni yang ni lah. Okay, yang ni. Okay, so this is your the TW, the pulse width. Okay, in this case here, yang ni. Okay, so this is a TW. Okay, how to get this TW? Okay, from here, okay, you can, okay, what happen here is, kamu tahu dia punya amplitude. Okay, this is the amplitude, logik daripada 0 sampai 1. Okay, so this is the digital logic lah. Okay, memang kamu tahu dia either logic 0 ataupun logic 1. So what happen here is to get the pulse width. So what you need to do here is you need to divide this one here at 50%. Okay, bahagikan di separuh. Okay, so this is a 50%. Okay, and then draw a straight line. Okay, kamu draw a straight line. Okay, so you see here. Okay, any value yang cross this straight line here. Okay, so from here to here, then we call it as a pulse width. Okay, yang ni adalah untuk pulse width. Okay, so means that daripada 0 1 kamu dapatkan yang tengah-tengah. Okay, so any intersection between this signal with this line here, 50% line here, so yang ni dengan yang ni kita panggil dia sebagai pulse width. Okay, next, kamu nak dapatkan rise time and fall time. Okay, what is a rise time? Rise time is the time for a pulse to go from low level to high level. Okay, yang ni lah rising age ni tadi. Okay, tapi since dia tak sharp, okay, dia tak berlaku pada waktu yang sama. Okay, so we need to find out what is the rise time. Macam mana nak dapatkan rise time? Okay, next, kamu dapatkan 90% daripada yang ni, and then 10% from this amplitude here, and draw a straight line. Okay, so lukis lagi straight line. Okay, whatever value that cross this line here, okay, so you know that, okay, so this is a rise time. Okay, di mana? Kenapa kita panggil dia sebagai rise time? Sebab yang ni logik 0 nak tukar kepada logik 1. So this value here, okay, this time interval between 10% to 90% here, so we call it as a rise time. Okay, which is the time for a pulse to go from logic 0 to logic 1. What about the fall time? Sama juga lah. Okay, whatever value that intersect between 90% and 10% lines here, so this is what we call it as a fall time. Okay, the time for the transition from logic 1 nak jadi logic 0. Okay, so from this waveform here, okay, this is the reality punya waveform. Kita boleh dapat dia punya pulse width, and at the same time we can get the rise time and fall time. Okay, any question up until here? Okay, this is the things yang kamu boleh calculate from the waveform. Okay, from the digital waveform. Okay, next. Okay, kamu dah tengok pulse width. Okay, now we're going to look at the duty cycles. Okay, apa pula duty cycles ni? Okay, so the duty cycle is the fraction of a time that a system is in active state. Okay, ataupun kita panggil dia sebagai operated state. Okay, active state. What is active state? Okay, dia kena bergantung pada ni lah. Tadi kan kita ada active high dengan active low signal. Okay, contohlah sistem tu dia adalah active high. Okay, so active state dia adalah dekat logik 1. Okay, sebab previously we have two active, sama ada active high, okay, which is logic 1, ataupun active low, logic 0. Okay, untuk contoh yang ni saya akan ambil yang active high lah. Okay, which is every logic 1 kita panggil dia sebagai active state. Okay, so macam mana nak dapat duty cycle? Okay, so duty cycle is the fraction of time that a system is in active state. Means that first kamu kena dapatkan dia punya TW. What is a TW? Inilah tadi. The pulse width. Okay, kamu dapatkan dia punya pulse width. Pulse width masa bila? Masa active state lah. Masa logic 1. Jangan dapatkan pulse width. Yang ni pun pulse width juga. Okay, from here to here. So this is also another pulse width. Tapi yang ni untuk logic 0. Okay, sebab yang ni at logic 0. But this one ya, untuk logic, okay, daripada sini ke sini, this is pulse width untuk logic 1. Okay, so kamu kena tahulah what is the active state. Sama ada it's logic 1 ataupun logic 0. Okay, in this case, logic 1. So the active state dia yang ni lah. Okay, kamu kena dapatkan dia punya pulse width. Okay, then after that, nak buat apa? Dah dapat pulse width, kamu kena divided by your T, your period. Okay, so TW over T darab dengan 100%, kamu dapat duty cycles. Okay, contoh. A periodic digital waveform has a pulse width 1 millisecond. And dibagi tahu situ period time 10 millisecond. Okay, so kamu tahulah. Okay, so yang ni dia punya T. Okay, T sama dengan 10 millisecond. And TW sama dengan 1 millisecond. So kamu nak dapatkan what is the duty cycle. So this duty cycle, okay, sama dengan TW. What is your TW? 1 millisecond. Bahagi dengan 10 milliseconds, which is your T, darab dengan 100. Okay, and then you will get 10%. Okay, so means that hanya 10% saja active state. Another 90% yang ni lah. Okay, 90% lagi adalah inactive state. Okay, so that is what the meaning of the duty cycle. Okay, contoh. Saya bagi another contoh. Okay, so you have a periodic digital waveform. Okay, dia punya TW sama dengan 10 milliseconds. Okay, T sama dengan 20 milliseconds. What is the duty cycle? Okay, can you find it? What is the duty cycle? Bolehlah, supaya kamu tahu. Okay, dia punya pulse width 10 bahagi dengan T 20 millisecond darab dengan 100, kamu akan dapat 50%. Okay, maksudnya kat sini, okay, kalau saya lukis, okay, yang inilah kamu punya signal. Okay, which is 50% adalah untuk active high and another 50% untuk active low. Okay, yang ni tadi 10% saja untuk logic 1, 90% lagi untuk logic 0. Okay, so that is what you can get lah from the duty cycle. Okay. Okay, and last but not least, apa yang kamu boleh dapat dari timing diagram daripada waveform is a timing diagram. So this is another things lah that you can get from the waveform. Okay, what is a timing diagram? Timing diagram is a graph of digital waveform showing the actual time relationship of two or more waveform and how each waveform change in relation to the others. Okay, so in the digital system, the amplitude usually the timing, not the amplitude. Okay, because the amplitude to represent a bit is pretty different. Okay, so in digital system, kita nak tengok pada dia punya timing ni. Okay, dia punya setiap edge ni. bukan kita nak tengok pada dia punya logic level. Bukan dia nak tengok pada amplitude. Sebab kita tahu dia punya amplitude sama ada 1 atau 0 saja. Okay, so kalau tengok pada rajah ni, okay, first kamu ada clock. So this is the clock source. Okay, kalau kamu tengok clocks ni, dia punya waveform dia adalah periodic. Okay, kenapa periodic? Okay, sebabnya dia punya T ni sama from cycle 1 to cycle 2. Okay, so T1 sama dengan T2 sama dengan T3. So this is a periodic clocks. Okay, then after that, okay, kamu ada 3 gates kat sini. Okay, so yang ni sekejap ya, saya check dulu. Okay, so kamu ada 3 waveform. Okay, waveform yang pertama kita panggil dia sebagai waveform A. Waveform kedua kita panggil dia sebagai waveform B, and waveform ketiga kita panggil dia sebagai waveform C. Okay, so this is what we call it as a timing diagram lah. Kamu ada clocks and kamu ada inputs. Pada masa yang sama nanti kamu akan ada outputs. Okay, saya bagi contoh Saya bagi contoh. Okay, nampak tak saya punya ni?
Nampak doktor, nampak.
Okay, so ni saya bagi contoh lah ni. Okay, kamu akan ada satu logic gate. Okay, so yang ni input. Okay, so belah kiri ni kita panggil dia sebagai input. And kanan dia is output. Okay, so sekarang saya nak draw logic, timing diagram. Okay, so this is the clock. Okay. Okay, so give this input A. And this is input B. Okay, so sekarang ni kamu nak dapat apakah kamu punya input, output F based on this timing diagram. Okay, so first mula-mula kamu kena identify dulu. Okay, what is this logic circuit? Okay, kita pakai gate apa sini? Okay, kalau by looking at this symbol, you know that this is an AND gate. Okay, di mana kamu ada 2 input A and B, 1 output F. Okay, so sebelum kita dapatkan F punya timing diagram kat bawah ni, okay, sebelum kamu lukiskan kamu punya F punya timing diagram kat bawah ni, kamu kena tahu dulu apakah dia punya truth table of this logic gate AND gates. Okay, nanti kamu belajarlah yang ni. Okay, so in this case here, kamu ada 2 input. So saya lukis dia punya truth table. Okay, yang ni kita panggil dia sebagai truth table. Okay, kenapa truth table? Sebab dia ada inputs. Okay, belah kiri ni kita panggil dia sebagai inputs. And kamu akan ada outputs. Okay, so this is what we call it as a truth table. Okay, so untuk AND gates, okay, dia punya persamaan Boolean equation, okay, F sama dengan AB. Okay, so this is dia punya Boolean equation. Ataupun kita panggil sebagai logic expression pun boleh juga. Okay, so Boolean expression untuk AND gates adalah F sama dengan A dot B. Di mana, okay, kalau kamu tengok this is a truth table, kamu akan ada combination logik 00, 01, 10, 11. Okay, so untuk yang ni, daripada truth table ni, kalau kamu tengok ni, berapa banyak dia punya combination of logic? Ada 4. Macam mana kita nak tahu ada 4 ke, ada 8 ke? Kamu kena pakai formula ni. 2 power of n. N adalah bilangan input. Okay, di mana sekarang ni input kita ada berapa? Ada 2. Okay, 2 kuasa 2, so total combination of logic input ada 4. Okay, so that's why kamu ada 00, 01, 10, 11. And from this Boolean equation, kamu tahu bila kosong and with kosong, output dia akan produce kosong. 01, 0, 10, 0, 1, 1. Okay, so from here, barulah kita boleh lukiskan kita punya output timing diagram ni. Okay, so saya nak lukis. First, kita tengok ni. Kalau kamu tengok ni logik apa ni? Logik 0, logik 1, betul tak?
Ya, betul. Kosong.
Yang ni first cycle, second cycle, third cycle, fourth and fifth. Okay, so yang ni 0 dengan 1, so dia akan produce 0. Okay, yang ni tengah-tengah ni 1 dengan 0. So masih lagi 0. What about this one?
1, 1, 1.
1. Okay, so dia akan jadi 1. 0, 1.
0.
0, 1, 0. 0, 0, 1, 0. So yang ni kamu punya timing diagram. Okay, untuk output based on this input. So yang ni lah yang ni sebenarnya timing diagram. Okay, di mana kamu ada inputs, kamu ada outputs and dapatkan dia punya output based on this input kat sini. Okay, sebelum dapatkan output kena tahulah circuit apa yang kita guna. Okay, yang ni basic circuit je lah, saya pakai AND gates. Okay, sebabnya nanti mungkin kamu ada circuit macam ni. Dapatkan F. Okay, so kamu kena buat analisis lah pada setiap satu gates ni. Apakah dia punya output and then dapatkan output terakhir. So this is what you going to look at the next chapter. Benda-benda ni. Daripada sini, dapatkan yang ni. Lepas tu buat dia punya truth table. Minimizekan circuit and all those things. Okay. Okay, so that is what you need to do lah nanti. Any question up until here? Ada soalan tak? Okay, saya habiskan dulu chapter 1 ni ya, sebab kita ada 2 slide lagi. And then kita ambil dalam 20 ataupun 20 minutes breaks. And then after that we continue back. Boleh ya?
Boleh.
Boleh tu.
Sekarang ni saya tengah share yang mana ya? Tak share apa-apa lagi ya?
Belum.
Tak ada.
Okay. Okay, so sekarang ni kita kembali semula kepada kita punya slide. Okay, so this is what happened lah for the timing diagram. Okay. Okay, now we look at this exercise. Okay, so a pre-digital waveform has a pulse width of 25 microseconds. Okay, dia bagi tahu TW sama dengan 25 microseconds and period T sama dengan 150 microsecond. Okay, so you're going to find out what is F and what is the duty cycles. Okay, boleh ambil 5 minit tak? Okay, get the result from this exercise. Okay, I give you 5 minutes to do it. Okay, so let's look at this F dahulu. Okay, so we need to find out what is F. Okay, F, what is the formula for F? F sama dengan 1. Okay, 1 over
1 over T.
Okay, di mana T is 150 microseconds. Okay, so you apa ni? Tekan calculator. Okay, you press down your calculator and you will get 6.67 kilo hertz. Betul tak? Okay, so this is your F. Okay, 1 over T. Okay, which is T is 150 microsecond. Okay, so kamu dapat 6.67 kilo hertz. Okay, what about the duty cycles? Okay, duty cycles, you know that the duty cycle is okay, pulse width bahagi dengan T darab dengan 100%. Okay, you will get TW. What is TW? 25 microsecond bahagi dengan 150 microsecond darab dengan 100 and you will get 25 bahagi 150. Okay, so kamu akan dapat 16.67. Betul?
Yeah.
Okay, so this is your duty cycle. Okay, so to review back what you have learned in the chapter 1. Okay, so hopefully you can define what is a digital and what is analog. Okay, and then you can explain the difference between analog quantity and digital quantity. Okay, so most of the time the analog is using a base 10 and digital quantity using a base 2 or binary numbers. Okay, you can hopefully that you can give an example of an analog system and digital system and a combination of both analog and digital at the same time. And hopefully you can state the advantage of using the digital system compared to analog system. Okay, there are a lot 5 or 6 advantage yang kita dah tengok tadi. Okay, which is not prone to the noise. Okay, easily to store, easily to design, and all those things. Okay, and then at the end you can define what is a frequency and period and duty cycles. Okay, so this is for the chapter 1. Okay, any question up until here? Okay, we already finished the chapter 1. Ada soalan tak from you?